So, why do we do the things we do? From our absolute best moments to our absolute worst. What is really going on? In this explainer, we're diving into Robert Sapolsky's incredible book, Behave, to build a framework that helps us unpack the science behind pretty much every human action. To get our heads around this, let's start with a real story, one Sapolsky shares about his own wife. Picture this. They're driving, some guy cuts them off, and after a little chase, his wife literally jumps out of the car, goes up to the other driver, and just flings something into his window. It was a moment of pure, unfiltered road rage. So, the big question is, why? Why did she do that? Was she just having a bad day? Is she an aggressive person? Something from her past? Well, Sapolsky's answer is kind of amazing. It's yes to all of it. See, to really understand any behavior, you can't just look at the moment it happens. We've got to peel back the layers of time, starting from 1 second before and going all the way back to millions of years ago. Okay, so let's start our journey just 1 second before she jumped out of that car. What was happening inside her brain in that single instant? Well, it turns out it was a biological tug of war. This conflict really boils down to two key players in your head. On one side, you've got the limbic system. It's ancient, super fast, and runs on pure emotion. It's your gut reaction. And on the other side, you have the frontal cortex, the slow, logical, effortful part of your brain that's trying to think about the consequences. Now, the star player for the emotional team is a little part of the brain called the amygdala. Think of it like your brain's alarm bell. It fires up whenever it senses fear or aggression. And it is incredibly fast. I mean, studies show that just seeing the face of someone from a different race for 50 milliseconds, that's a flash you don't even consciously see, is enough to light it up. So in that moment of road rage, her amygdala was just screaming threat. Pushing back against that alarm is the frontal cortex. And Sapolsky has this perfect way of describing it. It's the part of the brain that makes you do the harder thing when it's the right thing to do. It's that little voice of reason saying, hey, maybe getting out of the car and yelling at a stranger isn't our best move right now. Well, in this case, the amygdala won. Big time. But here's the thing. That 1 second battle in the brain didn't happen in a vacuum. So let's zoom out a bit. What was going on in the hours and days before this happened that might have primed her brain for that exact reaction? Turns out all sorts of things prime our brains. Hormones, for one. Testosterone, for example, isn't just about aggression. It's about amplifying our reaction when we feel our status is being challenged. Or what if she'd had a really stressful week? We know that sustained stress makes our emotional brain overreactive and weakens our rational side. Even tiny things in our environment, like words flashed too quickly to see, can shape how we act. Okay, now we're going to zoom out even further. The state of her brain on that particular day was also the product of her entire life, from the time she was a baby. How did her childhood, her teenage years, and the culture she grew up in sculpt the person who made that split-second choice? Our experiences literally build our brains. The bonds we form as infants wire our ability to trust. In childhood, we develop what's called a theory of mind, that crucial moment when we realize other people have thoughts and feelings different from our own. And adolescence, that's just a massive construction project for the brain. That frontal cortex, our center for impulse control, it's the very last part to get fully built. And check this out for a powerful example of these deep roots, the famous marshmallow test. You've probably heard of it. It showed that a little kid's ability to just wait for a second marshmallow, to delay gratification, could predict all sorts of things in their adult life, from SAT scores to social skills. Early lessons in self-control literally shape the brain for a lifetime. It's incredible. And then, of course, there's culture. You can think of culture as a software that runs on our brain's hardware. For instance, people from individualist cultures, like in the US, tend to explain behavior by focusing on personality. He did that because he's an angry guy. But people from more collectivist cultures are way more likely to point to the situation. He did that because he was under a lot of pressure. These are deep, automatic frameworks that shape how we see the world. All right, for our final layer, we have to go way, way back. We're zooming out to the timescale of centuries and even millennia. How have our genes and our deep evolutionary history as a species played a role here? First off, let's get something really important straight about genes. They are not destiny. Sapolsky's mantra is that genes don't determine behavior, they create tendencies. A gene might make you a little more sensitive to stress, but that only matters if you're actually in a stressful environment. Context Context is everything. And over millions of years, evolution has hardwired some pretty deep-seated tendencies in us. A classic example is something called kin selection. We are biologically biased to cooperate with and protect our relatives because, well, they share our genes. This ancient drive helps explain everything from a squirrel risking its life to warn its family about a hawk to the incredibly intense bonds we feel with our own families. So, after that whole trip, from a single second all the way back to the dawn of our species, what have we learned? What's the big takeaway from all these interconnected layers? The most important thing Sapolsky gives us isn't a simple answer. It's actually a new way of asking the question. To understand any behavior, whether it's an act of aggression or an incredible act of kindness, you have to run it through this explanatory funnel, working backwards through time, layer by layer. And at the end of the day, there is no single cause. The answer to why did she get out of the car is everything we just talked about. It's the neurobiology of that 1 second, the hormones from the past few days, the sculpting of her entire lifetime, and the deep echoes of our evolutionary past, all tangled up together. And all of this leaves us with a really profound and honestly kind of unsettling final question. If every single one of our actions is the product of this cascade of causes, stretching back through time, so many of which are totally outside our control, where does that leave free will? It's a question that really challenges our most basic ideas about choice, responsibility, and what it even means to be human.